we are going to see how to solve fourth degree polynomial equations, and these are also called the quadratic equations. And here are the common techniques that you should know. For the first one, we have x to the fourth power minus 81 is equal to 0. In general, we want to have the polynomial it's equal to 0 so that we can try to factor the polynomial. That's our best bet. In this case, we have two terms, x to the fourth power minus 81, right? And notice that they are both to the second power. Let me explain. For the first one, we can look at it as something to the second power, and likewise for the second one, we can look at it as something to the second power. Well, what's in the first parentheses though? It will just be x squared. Because x squared, you multiply the exponents, you will get 4. Next, to get 81, what square will give us 81? Well, 9, right? Just use positive 9. Okay, now, with that being said, we have a difference of two squares now, and we can use the formula a squared minus b squared equals a minus b times a plus b. And that's how you factor a difference of two squares. So, applying that formula, we will get x squared minus 9 times x squared plus 9. And that's still equal to 0. And in fact, we can factor more. Because for the first one, we can look at this as x and then squared minus the 9, it's the same as 3 squared. So for the first one, we can factor that and get x minus 3 times x plus 3. But for the second one, when we have a sum of two squares, let me write this down, a squared plus b squared, this right here is not factorable. Technically, I should say with real numbers. You can factor it with the I, but maybe we can do that later. Right here, I'm just going to keep x squared plus 9, it's equal to 0. Now, we have all this factored it, and then all we have to do is just set each one equal to 0. And then solve them individually. For the first one, just add 3 to both sides, x is equal to 3. For the second one, subtract 3 to both sides, x is equal to negative 3. For the third one, minus 9 to both sides, and then take the square root to both sides so that the square root cancel. Make sure you put a plus or minus though. And then right here you see we have the negative inside of the square root. That's how we are going to get the I. So x is equal to both plus or minus. We have the I because of the negative inside of the square root, and then square root of 9 is equal to 3. So here we have it. We have 3, negative 3, and also positive 3i and negative 3i. Altogether, we have 4 solutions. This is a fourth degree equation, so we could have 4 solutions. Now, for the next situation, we have 3 terms. X to the fourth power minus 13x squared, and then plus 36 is equal to 0. Well, we have x to the fourth power, and this is x squared. We can actually look at this as a quadratic by in terms of x squared. So what do I mean? Well, in fact, we can actually do the tic-tac-toe method to factor this right away. Because we know x squared times x squared gives us x to the fourth power. Now to get 36, what times what will give us 36? We can use negative 3 times negative 12 or negative 6 times negative 6, all that, right? But we should think about how to produce negative 13 when we add up the numbers right here. So the correct combination that we'll use is minus 4 and minus 9. Put them down and check. I will cross multiply x squared times negative 9, which is negative 9x squared. And then we do the same, negative 4 times x squared. And as you can see, all the terms right here have x squared, so we can combine the terms in the middle. Negative 9x squared minus 4x squared does give us negative 13x squared. So that's the correct combination. Therefore, to factor this, we will end up x squared minus 4 times x squared minus 9. Now, you can set them equal to 0 individually and then take the square roots both sides after you move the numbers, or you can keep factoring it. Let's practice factoring. For the first one, we can factor it as a difference of two squares, x minus 2 times x plus 2. For the second one, x minus 3 times x plus 3. Right? Now, for the first one, once you set equal to 0, you will get x is equal to 2. So let's just go ahead and write down the answers. 2 for the first one, and then the next one will be what? Negative 2. And then the next one will be positive 3. And the last answer here is negative 3. So here we have our 4 answers. Now, we have 4 terms. Can we still do this by factoring? Our best bet is to do it by grouping. Let's see. Look at the first 2 terms and the last 2 terms. For the first 2 terms, we can try to factor out x cubed, and we will have what? X minus 5 left. Now, right here we have a plus. Go ahead and write that down right away. And then we see that 8 and 40, we can factor out an 8. And then we will be getting x left because it was 8x, but we took out the 8. And then here is negative 40, but we took out an 8. So just do negative 40 divided by 8. We get negative 5. So we can actually do this by grouping because we see the x minus 5 is in common. So factor it to the outside, and then we will have the rest, which is x cubed plus 8. And then this is equal to 0. Now, we can actually factor x cubed plus 8, especially if you want to get all the solutions for this part. Do not just move it to the other side like this. If you put the 8 to the other side, you get negative 8, and take the cube root to both sides. It looks like we just get x is equal to negative 2. If you just want real solutions, this is totally okay. But if you want complex solutions, then I will suggest you to factor it. So how do we factor this right here? This is actually a sum of 2 cubes. So let me remind you guys the formula. A cubed plus b cubed is factorable, and we get a plus b times a squared minus ab plus b squared. So this is what we are going to do. For the x cubed plus 8, that's x to the third power plus 8 is the same as 2 to the third power. So we can factor it, right? And then we will get x plus 2 times this, which is the a. We will have to square that. So we get x squared. Next, we have a minus because right here it says so, right? So minus. These two things multiplying together, so that will be 2x. Lastly, plus b squared, which is 2 squared. So that will be 4. So this right here is because of the 2 squared. Okay, so we have the x minus 5 in the front. Multiplying them all out, we get 0. Whew, a lot of work, right? But we're getting there. Now let's just focus on the factored form. Put the first one equal to 0. Put the next one equal to 0. And then for the third one, it's a quadratic. That's also put it and then make it equal to 0. For the first one, just add a 5 to both sides. So x is equal to 5. For the second one, subtract 2 to both sides. X is equal to negative 2. Now, for this one, it's not factorable with real numbers. Let's do it by completing the square. It's easier in this case because we have a 1 in front of the x squared already, and the coefficient of x squared is even. Whenever this is the case, completing the square is going to be easier. So you guys can check out my other videos for completing a square. Right here, I'll just show you guys how to do it. First, I'm going to move the 4 to the other side, so we will have this. Next, we are going to take 1/2 of the coefficient of x, which is -2. And then we have to square that. 1/2 of -2 is -1. Square that, we get 1. This is the number that we will have to add to both sides. After this, these three terms together will give us x minus 1 times x minus 1, which is just x minus 1 squared, and that's equal to -3. Then we can just take the square roots to both sides, cancel, and then put a plus or minus. So we can see x minus 1 equals plus or minus. Here we have the negative in the square root. So that will be the I. Square root of 3, we'll just keep that. Then we'll just have to add a 1 to both sides. And then we can get x is equal to 1 plus or minus I times square root of 3. So here we have our first answer, second answer, and then the third and the fourth answers. Now, let's try another quadratic equations with 4 terms. But if you look at this, if you try to do it by grouping with the first 2 terms and the last 2 terms, for the first 2 terms, we can factor out x squared, and we get 4x squared minus 1. And then this right here, I had to factor out a negative. 16 and 8 is just 8. And then that will give us x, and then negative 16 divided by negative 8 is positive 2. But now if you look at this and that, they are not the same. They don't have any common factors, so it doesn't look like we can continue. So we will have to try a different way to do it. Can we use the rational zero theorem and then maybe synthetic division after that? You can try, maybe, but you know what? I do see this right here. That's quite interesting. Instead of factoring by the first 2 terms and then the last 2 terms, why don't we try the first term by itself and then the last 3 terms by itself? What do I mean? Let's have a look. For the first term, I'm just going to leave it for now, but for the second term, I will factor out a -1. And then the rest, which is just x squared, right? And then it was negative 8x. We took out a negative, so it becomes a positive 8x. Negative 16 divided by -1, that will be positive 16. Okay? And then I don't need the 1, let me erase that. Okay, what does this do though? Notice these 3 terms together, we can factor it. We get x plus 4 times x plus 4, which is x plus 4 squared, isn't it? So it's actually a perfect square if you look at the last 2 terms. And the interesting thing is that if you look at the first term, 4 is the same as 2 squared. X to the 4th power is x squared and a square. So let me bring that down. So have a look. We have this squared minus this squared. So we can use the difference of 2 squares formula. So we can actually factor it. We will get the following. This is our a, which is 2x squared. And then we will have to minus. This is our b, the x plus 4. Don't just put down x plus 4 though. Make sure you put parentheses around it because you will have to distribute the negative. And then for the second parentheses, we have 2x squared and then plus, and then here we have the x plus 4. For this one, the parentheses doesn't really matter because you distribute the positive. It's not going to change anything, but we'll keep it though. So it's just like that. Now we can actually factor it. Now for the first one, we have a quadratic, 2x squared minus x, and then distribute it, we get minus 4, that's equal to 0. And for the second one, 2x squared plus x plus 4, it's equal to 0. So we just have to solve these two quadratic equations separately. Here, we don't have a 1 in front of the x squared. We can divide everybody by 2, but we will end up with fraction here. So I'm not going to do that. I'm not going to complete the squared. I will just use the quadratic formula for this. And let me remind you guys, when we have the quadratic equation in the standard form, x equals negative b plus or minus square root of b squared minus 4ac all over 2a. And this is the quadratic formula that you need to know. For the first one, let me just write this down right here. X will be negative, b is negative 1 right here. So we have negative 1 plus or minus square root b squared, which is negative 1, and then square that, minus 4 times a times c. A is 2, c is negative 4. And then all over 2 times a, which is just a 2. So let's focus on this right here first. Here, negative 1 is positive 1. And then for the inside of the square root, this right here is going to be 1. And then 4 times 2 is 8, times another 4 is 32. But this is a minus times a minus, so that will be a plus. So the inside is 1 plus 32, which is just equal to 33. So that will be inside of the square root. And then over 2 times 2, which is 4. Since square root of 33, you can't really simplify it. We can just leave it like that. Here will be the two answers. 1 plus or minus square root of 33 over 4. Now for the other one, which is very similar, let's do it as well. X will be negative. Here the b is positive 1. And then plus or minus square root b squared minus 4ac. A is 1. Sorry, b is 1. A is 2. And c is 4. And then all divided by 2a. A is equal to the 2 here. Now let's work this out. Here we get negative 1 plus or minus square root. Here we have 1. Let me just do this right here real quick. This is 1. And then minus 4 times 2 is 8. And then times another 4 is 32. So in this case, we have 1 minus 32, which is equal to negative 31. So that will be going on the inside. And then over 2 times 2, which is the 4. All right, almost done. Because now we notice there's a negative inside of the square root. So put it on the outside, and then we can get a complex solutions here. Put it on the outside and make the I, and then square root of 31 over 4. And then we are done. Just like that. Now for the last equation, notice that we have 5 terms. And I don't really think grouping works. You can try the first 2 terms and the last 3 terms. I don't think it's nicely factorable. And you can try the first 3 terms and the last 2 terms. I don't think it will work nicely. So let's use the rational zero theorem. And I'm just going to list out all the possible rational zero right here for you guys. First, we are going to look at the constant term, which is 2. And the factors of it is just 1 and 2, because only 1 times 2 is equal to 2. So we consider 1 and 2, but both the positive and also the negative version of it. And then we look at the leading coefficient, which is this 2 right here. The factors of it is 1 and 2. So we will have to take these divided by 1, both positive and negative. And then again, we take these and then divided by the other factor, which is the 2. Now, if you simplify this a little bit, all we have to check is the following. 1 divided by 1 is just 1. Positive, negative, we can just count them right here. 2 divided by 1 is just 2, and then positive, negative. And then here we have positive 1 divided by 2, so just 1/2. And again, both positive and negative right here. And finally, 2 divided by 2 is just 1, which is this situation. So we have these that we have to check. So just go ahead and try out. Let's see. I'm going to erase this right here first. Let's try our favorite number, which is 1. So if I do 2 times 1 to the 4th power minus 1 to the 3rd power minus 7 to the 7 times 1 to the 2nd plus 1 plus 2, do we get 0? Well, this is 2 minus 1 minus 7 plus 1 plus 2. That's 1 minus 7 plus 1 plus 2. That's negative 6 plus 1 plus 2. That's not going to work, right? So not equal to 0. So positive 1 doesn't work. And I will tell you, if you put negative right here, let's see, there will be a negative 1. So that will be positive, still positive, and then that will be positive now, still negative, that. So we will have 3 minus 7 minus 1 plus 2. That's negative 4 minus 1 plus 2. Again, not equal to 0. So you can also get rid of the negative version of that. So far, 1 and negative 1 wouldn't work. Now let's try when x is 2. So let's try the 2 right here. So 2 times 2 to the 4th power minus 2 to the 3rd power plus 7 2 to the 2nd plus 2 plus 2. Do we get 0? This is my question mark. Okay, 2 to the 4th is 16 times 2 is 32 minus 2 to the 3rd power is 8 minus 2 to the 2nd is 4 times 7 is 28 plus 2 plus 2. Okay, this right here is 24, and then if you do this is 24 minus 28 is negative 4, and then if you do this, negative 2 plus 2, you get 0, so it does work. So 2 is an answer, right? So let me just erase this now, and I'm going to write note x is equal to 2 is a 0, which means if you subtract 2 to both sides, x minus 2 is a factor of the polynomial. So that means we can break this down as x minus 2 times something else. And to figure this out, we can do synthetic division. So let's write down the coefficients. 2 x to the 4th power minus 1 x to the 3rd power minus 7 x to the 2nd power plus 1 x to the 1st power and 2. Now, since x is equal to 2 is a solution, we are going to use this 2 right here, put it here, and then just proceed. Here we will have bring down the 2, and then 2 times 2 is 4. Negative 1 plus 4 is 3. And then 2 times 3 is 6. Negative 7 plus 6 is negative 1. And then 2 times negative 1 is negative 2. 1 plus negative 2 is negative 1. And then this times this is negative 2. So the remainder is 0. Here will be the coefficients for this factor here. And remember, the power will go down by 1. So we started at x to the 4th power. Here we will have x to the 3rd power. The leading coefficient is 2 inside though. So 2x to the 3rd power plus 3x squared minus x and then minus 1. So just like that. Okay. But the thing is, if you look at the second factor, this is still a cubic. So to solve that, most likely we will have to use the rational zero again, right? And I will tell you, -2 wouldn't work. You can try it, but it wouldn't work. So we will just have to try +1/2 or -1/2. And I will tell you, +1/2 wouldn't work because I tried it before already. Let's try -1/2. I'll show you real quick though. If we do 2 times -1/2, right, plugging all the x's to the third power plus 3 times -1/2 squared minus -1/2 minus 1. This is 2 times, this is -1/8. So that's -1/4. This is 1/4 times 3 is 3/4. This is +1/2 and then -1. And let's get our common denominator. I need to multiply by 2 and 2 here. Multiply by 4 and 4 here. And -1 plus 3 plus 2 minus 4. This is 2 plus 2 is 4 minus 4. We do end up with 0. So that is an answer. So let me erase this now. So right here, I will say, note, x equals -1/2 is another 0. So in this case that, what will be the factor? Well, we want all the integers as the coefficients right here, right? So here we are going to multiply 2 to both sides. So just have a look. X equals -1/2. Multiply 2 to both sides. Add 1 to both sides. So we have 2x plus 1 is equal to 0. So we will have 2x plus 1 being a factor. Okay. Now, since right here it's just a technical part, I'm actually not going to do synthetic division because we have 2x plus 1. Usually for synthetic division, we are trying to divide it by x minus the number c, like this. But here we have the coefficient 2, right? So it might be confusing. I will just do the polynomial long division for you guys. So what's going to happen is this. We have the x minus 2 all the way from here. And then we also know that 2x plus 1 is a factor, and we will have to figure out the other factor. So to get this factor, we will take this, divide it by that, and we'll just do polynomial long division. And I will put it right here for you guys. Polynomial long division. We have 2x cubed plus 3x squared minus x minus 1. And on the outside, we'll put this, which is 2x plus 1. Now let's just focus on this right here a little bit. What you want to do is, you want to compare the first term on the inside, the outside. So 2x to the third power divided by 2x. We need x squared. So that's x squared, and we will have to line up right here. So let's put down x squared here. And then you will take x squared, multiply with both terms. So we will get 2x to the third power, and x squared times 1 is plus x squared. And for long division, you are going to subtract. The first term should be cancelled. They are. And the next one is 3x squared minus x squared. 3 minus 1 is 2, and then you have the x squared. Now, bring down the minus x, and then let's see the first term on the inside and the first term on the outside. So 2x squared over 2x. We need an x, so put down plus x. Take x times both terms. So we will have 2x squared plus x, and then subtract. So the first term is gone. Next, we have -1 minus +1. So negative 1 minus 1, which is negative 2x. And then bring down the minus 1. Now, negative 2x and the 2x. So negative 2x over 2x is just negative 1. So the last part right here, we need a minus 1. Minus 1 times that, and the minus 1 times 1. And as you can see, there is no remainder for this. Therefore, we have found our third factor. It's a quadratic. We have x squared plus x minus 1. Whew, this is such a long one, I know. Okay, we're almost done. Now, let's just do it right. From here, of course, we can see x is equal to 2. It's a solution. From here, of course, we know that x is equal to negative 1/2. Now, from here, we will have to solve it. So this is x squared plus x minus 1 is equal to 0. Use the quadratic formula. We have negative b. B is 1 plus or minus square root of b, which is 1, square that, minus 4ac. A is 1, c is negative 1. All over 2 times a, which is 1. Now, x equals negative 1 plus or minus, let's see, this right here is 1, and then 4 times 1 times 1 is just 4, but negative times negative will give us positive, so that will be 5. So that will be 5 inside of the square root. And let me erase this. And then all over 2 times 1, which is 2. So there we have it. In fact, for this equation, we have 4 real solutions.